This video will discuss the average velocity when an object is undergoing constant acceleration. Now, average velocity is defined as the displacement divided by the time interval, although it can also be thought of as an average of velocities, but only under some circumstances. So let's take a look at a particular situation. Let's say we have a person who is starting from rest and speeding up, walking faster and faster. And let's say they do so such that they have an acceleration of 2 meters per second per second. All right, well, let's take a look at what happens to their velocity. I'll make a little table here. And let's examine at time 0, 1, 2, and 3 seconds. At time 0, they're not moving. But at time 1 second, they are moving 2 meters per second faster than they were the previous second. So 2 meters per second. And then they again move 2 meters per second of time faster. So 4 meters per second. And then they move 2 meters per second faster than they did the previous second, or 6 meters per second. Now, if we take a look at this, we can notice, or we can determine, the average velocity over those 3 seconds. We can simply take the velocities that we have, divide by how many we have, and we end up with 3 meters per second as our average velocity. Now notice that 3 meters per second is exactly halfway from 0 to 6. And so under this condition of constant acceleration, the average velocity will be exactly between the two endpoint velocities. Now, the other thing we can note, make a graph here, and if we say that's 1, 2, 3 seconds, time in seconds, make that be 3, and up here we go 1, 2, 3, 4, 5, 6. This is velocity in meters per second, and that's 6. So after 1 second it was going 2, after 2 seconds it was going 4, and after 3 seconds it was going 6, and that makes a nice straight line, very consistent with an acceleration that's constant. And we'll notice that this average velocity of 3 meters per second not only is halfway through the 0 to 6 velocity interval, but also occurs exactly at 1.5 seconds, or halfway through the interval time-wise. Now, we don't even have to add up all of these velocities. In fact, frequently it will be useful to just examine the endpoint velocities, the beginning and the ending. So we could also calculate our average velocity by saying, hey, it started at 0, ended at 6, we have 2 velocities, add them up, divide by 2, and again 3 meters per second. And again, that will occur exactly halfway through the time interval 0 to 3 seconds. Now, this is a very powerful feature of constant acceleration systems. And that's because it's very easy to make a measurement, say, of average velocity. To measure the displacement and the time interval. And knowing the average velocity, then we can get at maybe either the ending or the beginning velocity. Or vice versa, we could figure out how far this object goes with this feature of the average velocity. So let's take this example and say the average velocity is 3 meters per second. And we know they traveled for 3 seconds. And therefore, the displacement is 9 meters. And so, knowing that the average velocity is is halfway between the beginning and ending velocity, and knowing that that velocity occurs halfway through the interval of time, is a very powerful feature. Now, the average